Okay, hello everybody. We're gonna go ahead and talk about a little bit more on the periodic table, but what information does the periodic table tell us about these elements? So, as we learned, the periodic table is an arrangement of elements in increase in atomic number and grouped by similar chemical and physical properties. The idea of electron configuration symbols not only the location of the element on the table, but also their characteristics, right? When we learned about electron configuration last chapter, it told us where that element was on that periodic table. Since the periodic table is arranged in a certain way, that placement will also tell us the characteristics of that element as well. So we can use the electron configuration to find the elements group, period, and block. So obviously we have a periodic table here. And here's the shorthand electron configuration. It's Fe, 2s2, 2p5. So we start at He, move on to 2s2, then we got 2p5. So 1, 2, 3, 4, 5. So we're talking about fluorine, okay? Now, fluorine is in group 17, so it's group 17. It's in row 2, but looking back on the idea of the S block, P block, D block, and F block, fluorine is in the P block. Now we got a new electron configuration. It's ArFS1. So we start at argon, Ar, Fs, 4s1. So that is potassium. So potassium is in column 1. So potassium is in group 1. Potassium's also in row 4, so potassium is in row period 4. Now it looks like potassium is in the S block, so potassium is in block S. Okay. Moving on to another electron configuration, we got xenon, 6s2, 4f14, 5d9. So we got xenon, 6s2, 4f14, and then 5d9. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're talking about gold, okay? Now it looks like gold is in column 11. So gold is in group 11. Gold is also in row 6. So gold is in period 6. It looks like gold is also in the D block. So gold has a block of D. Lastly, we've got a regular electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6. So we got 1s2, 2s2, 2p6, 1, 2, 3, 4, 5, 6, 3s2, 1, 2, then 3p6, 1, 2, 3, 4, 5, 6. That is argon. Looks like argon is in column 18, so argon's in group 18. It's also in row 3, so argon has a period of 3. And argon is also in P block, so its block is P. So it's kind of like a lot of review that we've done a couple times already, but just kind of solidifying that information. All right, now the periodic table tells us how many valence electrons an atom has. We kind of talked about valence electrons vaguely when we talked about Bohr models. It was one of the questions on that Bohr model trend activity you did. So just a little refreshers, the valence electrons are the electrons on the outermost orbital of an atom. So when you draw a Bohr model, that outermost orbital, the one that's farthest away from the nucleus, all those electrons on that orbital are called valence electrons. So pretty much any element in column 1 in group 1 has 1 valence electrons. Group 2 is 2 valence electrons. We don't really worry about any of the D block or elements or in the F block or elements. They just kind of get a little bit more complicated with that idea. So I'm just going to skip over them. Moving over to group 13, we got 3 valence electrons. Group 14 has 4, 5, 6, 7, and 8, and so on and so forth. So if I ask you to tell me how many valence electrons calcium has, well, Just look up on the periodic table, it has 2 valence electrons. Now, how many valence electrons does phosphorus have? You look up, it has 5 valence electrons because it's in that group that has 5 valence electrons. Hydrogen has 1 valence electron. Carbon has 4 valence electrons. Okay. So now one more thing the periodic table tells us, it's going to be very, very important from here on out in chemistry, is it tells us the type of ions and charges an atom can have / form. So ions is an atom or group of bonded atoms that has a positive or negative charge. Okay, so whatever element has a charge to it, we call them ions. There's 2 different types of ions. The first one are called cations. Now these cations are positive ions, and since they are positive ions, it means they lose electrons, okay? And then the other type of ion is anions. They are negatively charged ions, and they gain electrons. So whenever you see a positive charged element, you want to say, oh, it's positive, so it's gaining electrons. No, it's the opposite. Remember, electrons have a negative charge. So kind of think about it this way, okay? I gained a lot of negative friends. My negative friends are electrons, okay? If I gained a lot of negative friends, my life is going to become very negative, okay? Now, if I ended up getting rid of dropping those negative friends, I'm no longer friends with them anymore, I'm pushing them away, pushing away those negative electrons, my life will become more positive because I'm getting rid of those negative friends, those negative electrons, okay? So here are the charges. Group 1 elements are going to have a positive charge. Then we got +2 charge for group 2. Group 13 has +3 charge. Now group 14 can be plus or minus charge. Don't worry too much of which element's going to be positive, which one's going to be negative. We'll talk more about that in chemistry B. Group 15 is -3 charge. Group 16 is -2. Group 17 is -1. And group 18 has no charge at all. Okay. So let's go ahead and look at lithium. Now, lithium is in group 1, so that means we know it has a +1 charge. So with that idea as being positively charged, remember cations are positively charged ions, so we know it's a cation, okay? But how many electrons does it lose or gain? Well, since it's a positive ion, it's becoming positive, so it's getting rid of those negative friends, getting rid of those electrons, and it's +1 charge. That means it loses 1 electron. So it's a cation that loses 1 electron. Boron. Boron has a +3 charge, okay? Again, it's a positively charged ion, so it's a cation. Okay, if it's becoming more positive, it's getting rid of those negative friends. So that means it loses 3 electrons, okay, because it's a +3 charge. Now, bromine has a -1 charge this time. It's a negatively charged ion. So that means it's going to be an anion. And it's a negatively charged, it's becoming more negative. Remember, if you become more negative, you're gaining more negative friends. So it's gaining electrons, but since it's a -1 charge, it's gaining 1 electron. So it's an anion that gains 1 electron. Now oxygen, we know that oxygen has a -2 charge. Again, negatively charged ion is an anion, so oxygen is an anion. And it's becoming more negative. It's gaining more negative friends, more negative electrons. And since it's a -2, it's gaining 2 electrons, and it's an anion. Now phosphorus is a -3 charge, okay? So we know it's an anion because anions are negatively charged ions, okay? But it's becoming more negative. It's gaining more negative friends, gaining more electrons. And since it's a -3, it gains 3 electrons. Now calcium, back to our positive, is a +2. And anything that's a positively charged ion is a cation. Since it's a positive charge, it's getting rid of those negative friends. I want to have a positive life, getting rid of those negative friends. So it's losing electrons, it's losing friends, and it's a positive 2 charge, so that means it loses 2 electrons. Now tin. Tin's a little special case. It's in the column that it's either a plus or minus 1 charge, plus or minus 4 charge. So that means it can either be a cation or anion. Because it's plus or minus, it can be both. So that means they can gain or lose 4 electrons. Okay. So anything in that column is kind of both. They kind of, you know, just like depending on their circumstance, they'll take one side or the other. Then we got argon. Now, argon is a 0 charge. Does 0 have a positive or negative charge? No, so it's not going to be any type of ion. It's never going to be an ion. So it's never going to be an ion, and that means it doesn't lose any electrons at all. Okay. All right. And that is all I have. All right, that's it. Thanks, guys.